Alright guys, welcome. This is your video lecture all about acid rain. We're going to go through different acids and bases as well so that we kind of really understand this negative air pollution that we have. Remember, just to remind you where we've been, on Thursday we talked all about air pollution, the different kinds. Friday we spent the day discovering all about ozone, which is 3 oxygen molecules, the good and the bad kinds of ozone. But today is all about acid rain. So here's your notes for today. If you were face-to-face, you have the notes in your notebook. I prefer that you do it that way. That way you can color it, do what you need to do on it. If you are online, here's your copy right here. You open it up. Again, it's going to take you to this page right here. Make your own copy file. Make a copy, and you will put your text right in there. Here we go, though. All about acid rain. So what is acid rain? Acid rain destroys plants, pollutes water sources and soil, and erodes buildings. So acid rain is what happens when sulfur dioxide and nitrogen oxide interacts with water vapor in the air. It becomes this acid, and when it interacts with that water vapor, it can often even interact with that liquid water. It'll combine, creating a chemical that is very corrosive. Corrosive means that it damages things, specifically buildings, structures, and monuments, but eventually if the acid becomes strong enough, it could have negative impacts on plants, animals, and maybe even humans. So we are concerned about this air pollutant and the effects that it could have later on. Good. So in order to understand acid rain, we've got to think what is an acid and what's a base. So here's our pH scale. Remember, pH is measuring the concentration of hydrogen in a solution. It goes from 0 to 14, and anything that is labeled with a pH of 0 to 6.99999 is considered acidic. Anything that is labeled from 8 to 14 is considered alkaline, or basic is what the word that we would use. Now, a common misconception that you all have that I've found is that only strong acids are harmful, but this isn't true. Strong bases can also be really, really harmful as well. Now you read the scale right here, 7 is neutral. So any kind of acid that you find in the 5-6 range is pretty, it's not harmless, but it's not going to harm you too bad. And then as you travel down towards 0, it's going to become increasingly harmful and increasingly acidic. Same thing happens over here. So if you're looking at 8 or 9, it's not a very harmful pH. It's not going to hurt you, it's not a very harmful pH or a base. It's not going to hurt you. But as we continue going closer and closer to 14, we're getting stronger and stronger, meaning that the implications to your health might be stronger. Okay. Now again, 7 is completely neutral, and the only thing that is completely neutral is deionized water. Some of our local water sources are hopefully, all goal is for water to be around 7 for the pH to be neutral, but that's not necessarily what's happening. So we learned, if you remember back to the hydrosphere when we were testing these and looking at the water quality, so this isn't the first time you've heard this either. Our pH of Jones Lake is right around here at like 4.5, 4.7, sometimes 5, and that's really acidic for a fresh body of water. Normal bodies of water are right here, but remember we talked about it's really acidic because it is fed by runoff. And as it goes over the land, it picks up with it the acidity from the decaying leaves, and that's what makes the water so acidic, and it's also what gives it its characteristic brown tint. But again, we are talking just about acids and bases here. Remember, acid, anything from 0 to 6.999. Base, anything from 8 to 14. And then our neutral is 7 right here. Exactly 7. So 7.000001 to 14 is basic. 7, exactly 7.0 is the only thing that is neutral. And the more neutral it is, the less harmful it is in general. So let's go through some common substances here. We've got a lemon or lemon juice. Do we think this is an acid or a base? Hopefully you've predicted that this is an acid. Lemons are typically around 3 on our pH scale. they're typically around 2 on our pH scale, meaning that they're pretty acidic, actually. That's why they say you shouldn't chew on lemons or eat lemons, and you should really limit the amount of lemons that you, like real lemonade, like you shouldn't drink that, just pure lemon juice, because it is acidic and it can harm your teeth. What about this? We've got a glass of milk. Do we think it's acidic or basic? If you test milk, it's going to be acidic, but it's not very. It sits at about a 6 on our pH scale. Next, we have bleach. Do we think it's acidic or basic? Hopefully, you have identified the bleach as being basic. It is pretty basic. It sits at about 13, so that means it's pretty harmful. We can deduct this. You know, you don't really want to put pure bleach on your hands. Definitely wouldn't want to put it all over your skin or anything, and absolutely would never want to drink it, right? It's really harmful when you ingest it. Pretty harmful when you just put it on your skin. If you leave it on your skin long enough and you have sensitive enough skin, it can even cause blisters. So Clorox and bleach, yes, it is acidic or basic. All right, now I can't say the word here because it gives away whether it's an acid or a base, but that stuff, that juice that's in your stomach, what is that? Do you think it's acidic or basic? Again, I hope you've identified this as stomach acid. It is an acid, and it sits at about a 1 on the pH scale, which is pretty acidic. And that's good for where it is because it's in your stomach and breaking down the food that you've eaten. So that's good. This is blood. What do we think? Is it acidic or basic? Blood is basic, but only barely. Blood is about an 8 on a pH scale. So remember we said 7 was neutral. So 8 is a pretty neutral base, but yet it still is basic. And we've got a cup of coffee. A cup of coffee is considered acidic. Generally, we say that coffee, especially black coffee, is around 4 on our pH scale, 4 to 5. We've got ourselves a bar of soap. What do you think, acidic or basic? Hopefully, you might not have known, but soap or lye specifically, or not lye, just soap, is considered around a 12 on our base scale. Obviously, we've put for general because it's on us. We've added some other chemicals that makes it not so harmful, but if you put pure lye, which is what soap is generally made out of, that's pretty basic, and it can actually burn your skin if you don't mix it with other things. And we got ocean water. What do we think, acidic or basic? It should be ringing some bells. We've talked about this before. Ocean water is considered basic. It is at an 8.1 right now, but remember when we talked about the carbon dioxide in the atmosphere? It is causing that ocean water to become more and more acidic, so eventually it might not be as basic anymore, which, while it'll be tipping it towards the neutral scale, is not good for those pH-sensitive organisms like coral and tropical fish. We've got some pure water here. What do we think, acidic, basic? Trick question. It is neutral. Pure water. It sits at exactly a 7.0000000, meaning that it is neutral. And then lastly, we've got some of the worst of the worst. Our acid here that sits at our 0, or our strongest acid, is hydrochloric acid. This acid is so strong that if you were to put it on your skin, it would melt down to the bone. It is really strong. Although hydrochloric acid, being so strong, it does not dissolve plastics. We used to use this in one of my labs in college, and it burned a hole through a couple of my shirts. Even though we diluted it with water, so it was a very, very weak form of this, it still burned a hole through my shirt, and I had to use plastic rubber gloves to work with it. It's very crazy. And then here we have our basic substance, which is Drano or drain cleaner. Very, very basic, sits at the highest base we can be for the most part. It is pretty dangerous, but again, we use it to unclog drains. All right, caution again. Remember, one of the common misconceptions here is that only acids, strong acids, are harmful. That is not true. Strong bases can be very harmful as well. Again, let's look at that pH scale here. So we've learned a lot about the pH scale, but where does acid rain sit on this? acid rain actually sits about a 5.5, which means that it's getting to be pretty acidic. That's around, remember we said coffee is around 4 or 5, so that's a little bit less acidic than coffee, so it could do some damage. Right, so that's why we're looking at this and why we consider it an air pollutant, because it comes from the air. But the acidity of that rain can actually cause the falling apart is not the right word, but that's what's coming to mind. The destruction of property. So again, we're talking stone things, and I'll show you a picture at the end of this as to what acid rain might do to a structure. So again, acid rain is at about a 5.5, which is pretty acidic, meaning that it can do some damage. Here's how it forms though. So the sulfur dioxide or the nitrogen oxides are emitted into the air via factories or cars or whatever kind of pollutant we've got. Even carbon dioxide too can do this. The gases, the sulfur dioxide, SO2, nitrogen oxide, NO2, and carbon dioxide, CO2, those gases combine with our H2O droplets to form acids. When those combine, it's not when they're combined in the sky that we're causing so much of the issue. The problem is when it rains down and we've now got acid rain. That acid rain falls on structures and it can destroy the structures. Again, I'll show you a picture of that in a little bit. It can destroy plants, it can be harmful to wildlife, it can be bad for our soil, it can pollute our freshwater systems, and if you remember all the way back to our hydrosphere, we don't have a lot of fresh water to be polluting to begin with. So it is a big deal that this is forming, and we really want to do what we can to try and decrease the formation of acid rain. Good. Remember, recall from Thursday, is acid rain a primary or secondary air pollutant? I hope you were able to identify secondary air pollutant because the chemicals, the SO2, NO2, and CO2, sulfur oxide, nitrogen oxides, and carbon dioxide combine with something else. So they are emitted. That would be just primary if they were emitted, but they actually combine with another molecule to form our pollutant, our acid rain. So that combination, or that chemical reaction, makes it a secondary pollutant. Fantastic, and as promised, I will show you what a structure might look like, and this is one of your assignments later, but this is a structure that was impacted by the acid rain. So you can see the wonderful sculpture of the lady here. You can see all of her hair, you can see the folds of her clothing. We've got nice sharp lines. But after a while with the acid rain, it starts to destroy the sharp lines. We get there's another word for it. It starts with a D and I can't remember it. And it's kind of frustrating me, but it's okay. It starts to disintegrate the statue and the molecules right there until it becomes blurry and faded and you can't tell what it is. Now, with a statue, it's destroying art, and that's kind of a bummer, especially if it was made a long time ago. But think about other structures like buildings or structures that we use for like structural soundness of buildings or bridges or whatnot. So if it is doing this much damage to a statue, imagine what it's doing to our structures that we depend on day to day and how dangerous that could be. Okay, this is the end of your video lecture. I hope you enjoyed and have a great day. Make sure you fill out those notes and turn them in via Canvas. Goodbye.